To our next topic. Sebastian, get out a couple pieces of paper, please. All iPads should be closed. You do not, like, flat on the desks. I don't want any iPads propped up. Yes. Yep. Okay, so we are moving on. Please stop talking. We are moving on. We're not talking to our neighbors. Cooper, we're moving on. Thank you. We're moving on to linear systems. Linear systems is when we try to find an x and a y coordinate that will work for both equations. Okay, so somewhere along the way somebody decided they're called systems. I don't know why, but they are. So we're going to be looking at pairs of equations to see if a specific coordinate will work for both of them. So what we're really trying to determine is if I was to graph, I'm going to put this Post-it on here. You don't obviously have to put this on your notes. So if I had a coordinate plane here, right? And I had two lines on this coordinate plane. I had them in slope-intercept form, and I was able to graph them, right? If I wanted to find out where they would intersect, so let's say I have this line, right? And then I have, well, gray's not going to work well. Hold on. Where's a good color? And I have this line. Okay? Where they intersect is the solution. So when you have a graph, it's like pretty easy to see it, right? It's just going to be whatever ordered pair this would represent. So if this was, let's see here. If this was ordered pair 3, 4, that would be the solution to my system. The problem is you're not always going to be given it in a cute little graph and be able to find the intersection. You're going to be using substitution and elimination strategies that I'll teach you where it's not easy to draw the graph, right? Where it would not make sense to try to graph it to get an accurate intersection point. Please stop. So what we're going to be doing today is I'm going to be giving you two equations. And I'm going to give you an ordered pair. And you're going to see if it's a solution. So today we're starting very basic. You're literally just putting values in for x and y to see if they work. That's all we're doing today. But this is where we're headed, where you'll have graphs or you'll be given equations and you'll be taught how to substitute or eliminate. So let's go ahead and do our vocabulary. System of linear equations. Two or more equations that share the same x and y values. Right? And I'm writing them as an ordered pair because, again, it's always going to come back to what is our goal. We want to find out where those lines would intersect. Okay? Everything in algebra has to do with a coordinate plane, an x and a y. Everything, right? So when you were in 3rd and 4th grade and you were taught how to plot little ordered pairs, you didn't realize that you were going to be using those ordered pairs for the next 10 years. Because everything comes back to those ordered pairs. Okay? So a solution to a system the x, y order that works. And I'm going to put the word works in air quotes because that means that it works for both equations. It means that if I put this in here, yes, the left will equal the right.
Do you like my handwriting?
Yeah. Can you move it up? I need to see the title.
You can look at mine.
Can you read it out? What does it say?
Oh, it's not. It's a guy from Cobra Kai.
Is that an R or a plus?
Stop. It's a plus sign. You were literally just making fun of your own handwriting, and now you're telling me you can't read mine? No.
Well, no, because, okay.
No.
No.
How can you not read that?
Okay, so like I said, we have two equations. Those two equations are considered our system. So when I say we're going to be doing systems of linear equations, in your mind, you should be thinking of two equations. This one's in slope-intercept, or these are both in standard form, right? Sometimes they'll be given in slope-intercept. But it doesn't matter what form you're given because all we're going to do now is put the 2 and the 5 in for x and y. So I'm going to use colored pencils so you guys can see it better. You do not need colored pencils, okay? So we're going to have our x's be yellow and our y's be blue, okay? So what I'm going to do is I'm going to put the 2 where I see x's, and I'm going to put the 5 where I see y's. So my next step of this is to say 2 plus 5 equals 7. Well, yeah, 7 equals 7. So that's good. That one works. If the first one works, you need to see if the second one works. If they both work, it's a solution. If one of them does not work, it's not a solution. So if I have 2 times 2 minus 3 times 5 equals negative 11. 4 minus 15 equals negative 11. Both of them work, so yes. My answer would be that this ordered pair is a solution because it works for both. Yes? That's exactly what we're doing. Really, the only way to make a mistake here is to put the wrong value in for x or y. I'm sorry? Well, I can't help you with that, Cohen. That's something you're going to have to work out on your own. Right? So I put this 2 here. I put the 2 here. Put the 5 here. Put the 5 here. Does anybody have questions about this? Okay, guys, way too many conversations taking place. Griffin. No. I just called on you.
Well, yeah, but it just seems like you.
Did you have your hand raised before just when I just called on you?
No, I was trying to talk to you.
He raised his hand so that he could tell you, are you excused?
Griffin, man. I am not ignoring you. I'm trying to teach algebra.
Well, yeah, but I was trying to talk to you.
Yes, and I answered your question, and I said,
How does it look like an R?
And it would be.
and we're moving on.
I like her too.
Okay, so we're going to do the same thing. Notice that these are now in slope-intercept form. Right? So we're going to still put the x's and y's in. Make sure they're in the right location. Again, the only mistake you can really make here is to put the x's and the y's in the wrong place.
No.
So like if one doesn't work, will that be both doesn't?
No.
So I see here that the first one does work. So I'm going to keep trying with the second one.
Second one, no worky.
Oh, wait.
Second one, commit no worky.
Huh?
No worky.
Huh?
No worky.
So this one, the second one does not work.
No worky.
No worky.
No worky.
So this is not a solution,
One more time for
No work.
right? So as soon as you see that one of them does not work, and notice that a linear system can have 3 equations, right? It could have as many as you want. It's harder though to get that point on a line, on a plane. All right, let's go on to the next example.
First for check
second one, committing worky. There, worky. 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 Worky, worky.
Sebastian, please stop. So number 3 does work because it fits. So if I were to graph both of these lines, if I were to turn them into slope-intercept form and plot them and graph them, they would cross at that point. That's what that means. Yes? Okay. All right, so if I plug in this next one, 3 equals 8 times -1 plus 5. Does 3 equal -3?
No.
So you can stop. You don't have to even do the second one because this one didn't work. So my answer is no.
So if we just stop, so if we just stop on the test and didn't do 6 on it, still count
As long as you write no, yeah. You have to show me, right, your process. Okay, I'm going to come around with a practice page.
Yay!